Previously, we have learned how to prepare an alkene dengan dua cara, by dehydration of alcohol and also dehydrohalogenation of haloalkene. And now we are going to learn about the chemical reaction of alkenes. Basically, the main type of reaction in the chemical reaction of alkenes adalah electrophilic addition reaction. Okay, and there are few of the chemical reactions of alkenes yang akan menggunakan type of reaction electrophilic addition reaction of alkenes. Okay, but here are some of the chemical reaction of alkenes that you need to learn, such as hydrogenation, halogenation in inert solvent H2Cl2 or in aqueous solvent. Lepas tu Hydrohalogenation yang follow Markovnikovs Rule dan juga yang tak follow Markovnikovs Rule, because ada presence of peroxide. Next is about the hydration of alkenes, and lastly is about oxidation of alkenes. Okay, I believe chemical reaction 1 sampai 4 ni melibatkan electrophilic addition reaction. Okay, oxidation of alkenes ni is different kind lah. Okay, nanti kita akan go through this later. Tapi basically previously untuk preparation of alkene, you hanya kena belajar satu jenis mekanisme sahaja, which is dehydration of alcohol. Tapi untuk chemical reaction of alkenes, you just need to learn two reaction mechanisms of the chemical reaction of alkenes, such as hydrohalogenation yang follow Markovnikovs Rule and also hydration of alkenes. Okay. Okay, basically alkenes ni dia lagi reaktif compared to alkane. Sebab alkane dia ada carbon-carbon single bond, so dia hanya ada satu saja sigma bonds. Tapi kalau alkenes kan carbon-carbon double bond, so dia ada satu sigma bond dengan satu pi bond. Okay, and we have learned dekat subtopic 4.1 di mana carbon-carbon double bond ni dia sangat kaya dengan electron density. That's why dia adalah nucleophilic site. So nucleophilic site, pasangan dia ialah reagent yang miskin. Okay, reagent yang miskin, which we call it as electrophile. Okay, electrophile ni adalah reagent yang miskin. And mostly the type of chemical reactions of alkene ni adalah addition reaction. Kita dah belajar ada 4 jenis type of chemical reactions kan, which is substitution, addition, elimination, rearrangement. Okay, tapi alkene kebanyakannya akan buat addition reaction. And as what I told you dekat 4.1, addition reaction, the clue here kat sini, addition you akan add dua benda. So bila you add dua benda, basically kalau let's say daripada carbon double bond, you akan dapat carbon single bond. Okay, because you add dua benda dekat each of these carbon atoms. Alright, and kenapa nama dia electrophilic addition reaction, the type lah, kenapa nama type dia adalah electrophilic addition reaction is because dia menggunakan reagent electrophile. Okay, sebab carbon-carbon double bond ni di nucleophilic site, pasangan dia adalah reagent electrophile. So that's why the type of chemical reaction of alkene adalah electrophilic addition reaction. Okay, addition reaction of alkene ni ada 3 karakteristik. Yang pertama, apa yang berlaku bila buat addition reaction, the pi bond ni dia akan break down. Okay, supaya dia akan dapat dua new single bonds. Dia akan hasilkan dua new single bonds here. You can see lah. Contohnya, this is alkene. Dia buat addition reaction with this reagent. So at each of these carbon atom, okay, pi bond ni dia akan break down. So at each of these carbon atom dapatlah dua new single bonds. Kita akan add dua benda lah. In here, kita akan add X dengan Y ni. Okay. And then, you will only obtain one product at the end of the reaction. And the product yang diobtain, produk yang terhasil tu adalah saturated organic compound. Because kalau carbon-carbon single bond kan saturated organic compound. Kalau carbon-carbon double bond, unsaturated organic compound. So daripada unsaturated organic compound, sebab carbon-carbon double bond dibuat addition reaction, dapatlah jadi dia dapatlah hasilkan saturated organic compound, which is carbon-carbon single bond. Let's look at the first step of electrophilic addition reaction of alkenes yang dikenali sebagai hydrogenation. Okay, I want you to know keyword kat sini ataupun dia punya hint ialah hydrogenation. Kita tahu addition reaction ni kita akan add dua benda kan? We will add dua benda. So kalau hydrogenation, that means dia add dua hydrogen. Okay, let's look here. For example, kalau let's say alkene dia buat hydrogenation, dia akan gunakan reagent hydrogen and also catalyst sama ada platinum ataupun nickel or palladium. Okay, tiga-tiga ni hanya suggestion, but then bila nanti when it comes to writing down the hydrogenation reaction ni, you kena make up your mind lah nak choose which one of the catalyst that needs to be used. Okay, so you can see here, this is alkene. Bila dia buat hydrogenation, dia buat electrophilic addition reaction kan. So daripada carbon-carbon double bond jadi carbon-carbon single bond. Okay, so akan ada dua benda yang will be added here, which is hydrogen. Okay, dua hydrogen. So kiranya at each of these carbon atoms will get one hydrogen, each of them. Okay, for example, you can see here. Okay, this is the alkene. Okay, so bila dia buat hydrogenation, because dia gunakan reactant hydrogen dengan catalyst sama ada platinum, nickel or palladium, tak boleh buat macam ni. Kena choose which one. Okay, for example, I want to choose catalyst nickel. Therefore, daripada carbon-carbon double bond jadi, sebab dia buat electrophilic addition reaction, jadilah carbon-carbon single bond. And you can see dekat this carbon, dia add satu hydrogen atom, and also at this carbon atom pun dia add satu hydrogen atom. And you can see here, this carbon dia jadi single bond, tapi dia dah terisi lah hydrogen kat situ, hydrogen atom. And at this carbon atom pun daripada ada dua hydrogen, dia bertambah jadi tiga hydrogen. Okay, because kita add hydrogen atoms dekat hydrogen atom at this carbon atom. Alright. Next, if you look at this is a cyclic compound untuk alkene. This is cyclohexene. Okay, so it is a skeletal structure. So I would like to letak carbon kat sini so that you can see it. So each of these carbon atom hanya ada satu saja hydrogen at each of them. How do you know? It's because satu carbon atom boleh ada maksimum 4 covalent bond. So kat sini this carbon atom supposedly ada 1, 2, 3 covalent bond. Therefore covalent bond yang keempat adalah with hydrogen atom at each of them lah. Okay, and then bila dia buat electrophilic addition reaction jenis halogenation, di mana dia akan gunakan reactant ataupun reagent hydrogen and also catalyst platinum. So daripada carbon-carbon double bond ni, okay, carbon-carbon double bond dapatlah jadi carbon single bond. Okay, sebab kita isi dengan apa? Kita isi dengan hydrogen at each of the carbon double bond ni. Okay, each of the carbon atoms dekat this carbon double bond. Therefore, nanti bila dia jadi single bond, makanya dapatlah dua hydrogen atoms at each of them. Alright. The next type of electrophilic addition reaction of alkenes that you need to learn is about halogenation of alkenes. Basically, halogenation of alkenes ni can be done in dua jenis solvent, such as in inert solvent dengan aqueous solvent. But yang in aqueous solvent tu you will learn it in the next slide lah. For this slide, it's about halogenation of alkenes in inert solvent, CH2Cl2. Basically, you will add dua benda. Kalau let's say in inert solvent CH2Cl2, which is you will add dua kali halogen. Okay. For example, if let's say alkene dia buat halogenation, dia akan gunakan reagent halogen such as Cl2 ataupun Br2. Okay, in inert solvent memang CH2Cl2, sama ada CH2Cl2 ataupun CCl4. Okay, so kalau you nampak CH2Cl2 atau CCl4, that is actually inert solvent. So basically kalau halogenation in inert solvent senang sikit because you just need to add dua halogen at each of these carbon double bond punya carbon atoms. Okay, so daripada double bond carbon double bond ni jadi carbon single bond because you add satu halogen at this carbon atom and satu lagi halogen at this carbon atom. Okay, so you add dua halogen lah, faham? For example, as you can see here, this is an alkene organic compound. Okay, kita highlightkan part carbon double bond. Okay, because this is the nucleophilic site, and this is the site where you need to add the halogen. Okay, so kat sini digunakan halogen Cl2 inert solvent CH2Cl2. So bila you nampak saja this kind of combination, you will know that this is halogenation of alkenes in inert solvent. Therefore, dekat each of these carbon atom, you kena add halogen. Halogen atom yang digunakan kat sini ialah Cl. So this carbon will get Cl and this carbon pun will get Cl. Okay. So daripada double bond, jadilah single bond and each of them dapatlah Cl atoms. Faham? Kalau electrophilic addition reaction yang melibatkan halogenation of alkenes in aqueous solvent H2O, you need to add dua benda, tapi dua benda yang akan di-added tu adalah halogen and also OH. Okay, for example, if let's say alkene, dia buat halogenation in aqueous solvent, okay, halogen tu boleh jadi Cl2 atau Br2, makanya dekat carbon double bond ni, dekat this carbon double bond nucleophilic site, we will add at each of them salah satu carbon yang akan dapat halogen, salah satu lagi akan dapat OH, di mana this is organic compound, nama dia adalah halohydrine. Okay, tapi dia ada cara-cara dia untuk you add halogen dengan OH ni. Okay, so it is not sesenang macam in inert solvent lah. Okay, di mana kita add dua-dua halogen, so tak perlu nak fikir nak add halogen kat mana, OH kat mana. Tapi when it comes to in aqueous solvent, you need to be careful a bit, you need to remember this. Okay, bila halogenation in aqueous solvent ni, you need to add halogen, ada carbon yang ada banyak number hydrogen. Okay, ingat tu lah, kalau you nak add halogen, you kena add ada carbon with a greater number of hydrogen. Okay, kalau you nak add OH pula dia akan dekat carbon yang sebaliknya lah, carbon yang tak banyak bilangan hydrogen. Okay, so you can look at these examples and you can try this one. Okay, kita tengok example yang pertama dulu lah. At this carbon double bond, dia ada same number of hydrogen atoms, so tak jadi masalah lah you nak add halogen tu dekat mana-mana carbon and also OH dekat mana-mana carbon at this carbon double bond. Okay, so at this first example, dia buat halogenation in aqueous solvent, so you need to remember addition reaction halogenation in aqueous solvent, you akan add dua benda, you akan add halogen, you akan add OH. Okay, so in this case dia gunakan halogen Br. And since that this carbon double bond, dia punya bilangan halogen dia sama rata, so tak kisahlah you nak letak OH kat sini, Br kat sini pun okey, you nak letak OH kat sini, Br kat sini pun okey. Okay, asalkan you add dekat this nucleophilic site, the carbon double bond. Okay, and then next, if you look at this cyclic compound, okay, this is the site yang kita akan add halogen dengan hydrogen tu. So kita bawa keluar carbon, okay, bawa keluar carbon atoms, and then you covalent bondkan this carbon. So this carbon dah ada 1, 2, 3, 4, 1, 2, 3, 4, therefore dia tak ada hydrogen langsung. This carbon 1, 2, 3, therefore covalent bond yang keempat adalah dengan hydrogen. So this carbon at least dia ada satu hydrogen atom. This carbon memang tak ada langsung hydrogen atom. Therefore, you rujuk balik kat bawah ni, Okay, you kena ingat balik benda ni tak diberi dalam exam pun. Tapi you have to remember that you need to add halogen. Okay, you need to add halogen, ada carbon yang ada greater number of hydrogen atom. Therefore, at this carbon atom, I will add the halogen. Okay, halogen yang digunakan kat sini ialah Cl2. Alright, so I will add Cl at this carbon atom. Okay, so that carbon atom will get the halogen Cl, while at this carbon atom, since that dia tak ada langsung hydrogen atom, dia akan dapat OH. Okay, so dia ada rules lah bila nak add when it comes to halogenation in aqueous solvent. So daripada this carbon-carbon double bond, jadilah carbon-carbon single bond di mana at this carbon atom kita akan letak Cl, at this carbon atom kita akan letak OH. Alright, so you can look at this one juga to try it out. I believe this carbon atom kita akan add OH since that dia tak ada hydrogen langsung. This carbon atom dah ada satu hydrogen, therefore akan add halogen. Halogen apa? Halogen yang digunakan kat sini adalah Br. Br2, therefore akan add Br. Br lah, satu Br, satu OH. Okay, so nanti you lukislah kat sini how it looks like. So I believe it will look something like this. Okay, CH3, and this one ialah kat atas ni OH, lepas tu Br. Okay, alright. Okay, so the next type of electrophilic addition reaction of alkenes that you need to learn is about hydrohalogenation that follow Markovnikovs Rule. As what I told you earlier, kalau electrophilic addition reaction of alkenes, reaction mechanism yang you have to learn ada dua sahaja, and one of it is about hydrohalogenation that follow Markovnikovs Rule lah ya. So nanti later kita akan learn the reaction mechanism of this. Okay, so basically, kalau let's say hydrohalogenation, okay, the clue here, you akan add dua benda apa ya, hydro and halogen, okay, hydro and halogen. Basically, kalau you buat hydrohalogenation, you will do addition of hydrogen and also halogen dekat this carbon-carbon double bond, okay. And the reagent yang digunakan adalah HX. X tu adalah halogen sama ada Cl ataupun Br. So basically kalau alkene, dia react dengan HBr ataupun HCl. Basically dia akan buat hydrohalogenation. Therefore you will add hydrogen dan halogen dekat this carbon-carbon double bond. Tapi ada cara-caranya untuk add the hydrogen dengan halogen because dia kena follow Markovnikovs Rule. Okay, so apa tu Markovnikovs Rule? Markovnikovs Rule cakap, okay, kalau let's say your alkene ni dia unsymmetrical, dia tak sama bilangan hidrogen dia, okay. Macam contohnya ni terlebih hidrogen ke ni kurang hidrogen, okay. Therefore, bila kita nak add the hydrogen tu, the hydrogen atom will be added to the carbon double bond yang ada banyak number of hydrogen atoms, okay. Halogen pula will be added to the carbon dekat double bond ni yang ada fewer number of hydrogen atoms. Inilah dia Markovnikovs Rule for hydrohalogenation. Okay, so let's look at some of the examples for hydrohalogenation that follow Markovnikovs Rule. Markovnikovs Rule ni you have to remember this ya, sebab sometimes dia tanya apakah rule yang you have to apply when you are doing the hydrohalogenation of alkene. So you have to say Markovnikovs Rule ni cakap hydrogen atom will be added to the carbon atom of the double bond yang ada banyak number of hydrogen atoms. Okay, for this one, this is actually a symmetrical alkene. Okay, kenapa dia symmetrical alkene? Because dekat carbon-carbon double bond ni ada sama bilangan hydrogen atomsnya. Okay, therefore bila dia add dengan reagent HBr, therefore kita tak kisahlah you nak add hydrogen ni kat mana-mana pun, nak tak hydrogen kat sini pun okey, nak tak hydrogen kat sini pun okey, because it is a symmetrical alkene. Yang pastinya bila dia buat addition reaction daripada carbon-carbon double bond dapat jadi carbon-carbon single bond. Itu yang penting lah, and also this is the two things yang added to this carbon-carbon double bond. Okay, next is this kind of alkene. This alkene is unsymmetrical alkene. Okay, dia asymmetrical. Kenapa asymmetrical? Because dekat carbon-carbon double bond ni, bilangan hidrogen dia tak sama. Okay, dekat this carbon double bond, dia ada 2 hydrogen atom. Dekat this carbon double bond, tak ada langsung hydrogen atom. Okay, tapi bila dia buat hydrohalogenation with reagent HBr, you need to remember that you need to follow Markovnikovs Rule. Okay, Markovnikovs Rule cakap apa? Dia cakap bila you nak add hydrogen atom to the unsymmetrical alkene, you need to add the hydrogen kepada carbon double bond yang banyak hydrogen atoms. In this case, this carbon will receive dia akan add hydrogen dekat sini. Dekat this carbon kita akan add halogen. Okay, halogen in this case ialah Br. So you can see here, this carbon-carbon double bond dah jadi, sebab dia buat addition reaction, dia jadilah carbon-carbon single bond. Cumanya dekat this carbon kita add hydrogen, so daripada 2 jadi 3. And dekat this carbon atom kita add the halogen Br. Alright, so this is how it looks like. For this alkene pun is still the same. It is asymmetrical alkene. So bila dia asymmetrical alkene, you need to add the hydrogen atom kepada carbon double bond yang banyak hydrogen atoms. Okay, so this is the carbon-carbon double bond. Okay, yang site yang terlibat untuk kita buat addition reaction tersebut. Okay, if let's say dia gunakan reagent HBr like this, this hydrogen will be added to this carbon double bond, and this Br will be added to this carbon double bond. Okay, so therefore terhasillah major product di mana kita add hydrogen pada carbon double bond yang banyak hydrogen atoms, and also daripada carbon-carbon double bond dapat jadi carbon single bond, ya, sebab this is addition reaction. And then dekat this carbon atom dia dapat halogen, which is halogen Br. Kenapa ada major dengan minor? Because major product adalah the one yang follow, okay, follow Markovnikovs Rule. Okay, the one yang unfollow Markovnikovs Rule, itulah dia minor product. Okay. Okay, so let's look at the overview for the reaction mechanism hydrohalogenation of alkene. For example, kalau you ada alkene, di mana this is actually asymmetrical alkene, di mana this carbon double bond ada banyak hydrogen atoms, this carbon double bond tiada langsung hydrogen atoms, okay, and they react dengan reagent HCl untuk buat hydrohalogenation of alkenes daripada double bond jadi single bond. Okay, so if let's say you tak tahu nak buat reaction mechanism, you boleh buat dulu macam ni. Okay, sebab kenapa? Because at least you boleh tahu the major product ni apa. Reaction mechanism nanti kita akan go through this later. So basically dekat this carbon atom, kalau according to the Markovnikovs Rule, so you kena ingat this one dia akan follow Markovnikovs Rule. According to the Markovnikovs Rule, this carbon atom will dia akan dapat hydrogen atom, and this carbon atom will be dia akan dapat Cl. Okay, so you can see here daripada double bond jadi single bond. Okay, so dia punya reaction mechanism dia macam mana, kita dah tahu dah dia punya produk dia apa. So make sure bila you buat reaction mechanism, you akan dapat the major product yang you have done here lah. Okay, so what happen here is, kalau let's say alkene ni, dia punya reaction mechanism dia, it will start with alkene dekat double bond ni, dia akan attack the hydrogen of the, kalau let's say you guna HCl, kalau HBr, HBr, tapi dia akan attack this hydrogen because dia akan ambil this hydrogen atom. Okay, lepas tu this hydrogen atom dia akan buat heterolytic cleavage, dia akan pisahkan bond dia bersama dengan halogen, and it's actually a slow reaction. Okay, and next what happen is, kan bila let's say this double bond dia attack hydrogen atom, makanya one of the carbon-carbon double bond ni dia akan dapat positive charge, and then one of the carbon double bond ni akan receive the hydrogen. So if you want to know which carbon yang dapat positive charge, which carbon yang dapat hydrogen tu, you have to remember about Markovnikovs Rule. Okay, since we know that this carbon dia banyak hydrogen atom, therefore this carbon dia akan dapat the hydrogen. Okay, this carbon dia akan dapat the hydrogen, manakala carbon yang sebelah ni, carbon double bond sebelah ni, dia akan jadi carbocation. Okay, how about the Cl? Because we already break the bond between this H dengan Cl heterolytically, therefore this Cl dia akan dapat negative charge, dia akan jadi anion. So next is a fast process. It's when anion ni dia attack this cation. Anion ni dia attack specifically, this is a carbocation. So it's a fast reaction because daripada negative charge ke positive charge, therefore dapatlah dekat this carbon Cl. So my tips is, please buat macam ni dulu sebelum you nak buat reaction mechanism, so that you will know the major product tu apa. Okay. Okay, actually ada dua je steps untuk reaction mechanism for hydrohalogenation of alkene. The first step is the formation of carbocation, and it is a slow process. Okay, so apa yang berlaku kat sini, you lukis you punya alkene and reagent yang digunakan, which is sama ada HCl atau HBr. In this case you guna HCl, and please tulis arrows with perkataan slow ke atas, because this is actually a slow reaction. So what happened here is, bila you nak form carbocation, okay, kita akan show arrow daripada double bond ni, dia pergi attack this hydrogen. Okay, lepas tu, lepas dia attack this hydrogen dia akan berpisah bond dia bersama this halogen Cl. Okay, therefore you need to lukis another arrow daripada this bond kepada halogen. Alright, so bila double bond dia attack this hydrogen, akan ada satu carbon double bond ni yang akan receive hydrogen atom, akan ada satu lagi carbon yang akan dapat jadi carbocation. In this case, bila nak buat formation of carbocation, please remember about Markovnikovs Rule. Okay, Markovnikovs Rule. Because Markovnikovs Rule cakap carbon double bond yang banyak hydrogen atom lah yang akan dapat hydrogen. Okay, so therefore, if you look at this carbon-carbon double bond, we know that this carbon will get the hydrogen atom. But how about this carbon? This carbon dia akan dapat jadi carbocation. Okay, and then you have to make sure after dia buat attack tu dekat this double bond, daripada double bond dia akan jadi single bond. Okay, and carbon yang dapat hydrogen ni yang the ones yang follow Markovnikovs Rule. How about the Cl atom ataupun halogen tersebut? Halogen tu lepas dia dah break the bond ni, you nampak kan this arrow, it starts from the source of the electron which is at the bond, and then dekat hujung elektron ni, Cl ni dia dapatlah 2 elektron, sebab tu double headed arrow. Therefore, because Cl ni dia receive the electron, dia akan dapat negative charge. Alright, next is the rapid reaction with negative ion. Okay, rapid reaction with negative ion, you salin balik saja produk yang dah dapat kat sini. Okay, ni kalau buat step by step tau. Kalau you dah pro ataupun dah okay, you nak buat macam overview like the previous slide, is fine, as long as ada slow dengan fast punya arrow, slow and fast punya reaction. Okay, so this is a rapid reaction because basically negative ion dia attack the positive ion. Okay, and ion dia attack cation. In this case, this is a carbocation. So That's why it's a fast process sebab terus dapat Cl dekat bawah this carbon. Okay. For the next hydrohalogenation that you need to know is the one yang anti-Markovnikovs rule, yang disobey Markovnikovs rule. Okay, we know that Markovnikovs rule cakap hydrogen tu must be added to the carbon double bond yang banyak hydrogen atoms, but anti-Markovnikovs rule basically dia tak akan follow Markovnikovs rule. That means the hydrogen will be added to the carbon double bond yang paling sikit hydrogen atom. Okay, that will happen if only alkene dia react dengan reagent HBr in the presence of peroxides. Peroxides ni dia punya general formula dia ialah ROOR. Okay, di mana R ni it can be either hydrogen ataupun any alkyl groups. Okay, any alkyl groups. So, tapi yang paling famousnya ialah H2O2. Kalau let's say you nampak alkene react dengan HBr with H2O2 ataupun sometimes HOOH, you have to know that that is actually a peroxide. Ataupun dia buat CH3OO CH3, that this one pun boleh jadi peroxide. Okay, tapi asalkan dia punya general formula dia ialah ROOR. Okay, therefore it is actually hydrohalogenation that is not following the Markovnikovs rule. Okay, so tapi benda yang you add sama saja. You will add dua benda, which is hydrogen and also halogen. Cumanya dia tak follow Markovnikovs rule. For example, kalau let's say this is the alkene yang react with HBr in the presence of peroxide, therefore it will disobey Markovnikovs rule. So kalau bila you nak add the hydrogen, you have to add the hydrogen to the carbon atom yang paling sikit bilangan hydrogen atoms dekat the carbon double bond lah. Therefore kalau let's say this is the alkene yang anti-Markovnikovs rule tu, hydrogen ni will be added to this carbon double bond. Since that this carbon double bond tak ada langsung hydrogen atom, this carbon double bond ada hydrogen atom, so kita akan letak halogen kat situ lah. Okay, for examples, you can see here, this is the carbon-carbon double bond. Okay, bila carbon-carbon double bond ni, alkene ni, dia reactkan dengan HBr in the presence of peroxide. Okay, please lah kalau let's say dalam exam, if let's say you nak buat contoh for hydrohalogenation yang anti-Markovnikovs rule, you have to insert the real peroxide, jangan buat ROOR. Okay, so you have to gantikanlah, buatlah HOOH pun jadilah, ya. To show that this is peroxide, therefore it will not follow the Markovnikovs rule. So if you look at this carbon double bond, dia ada satu hydrogen. Dekat this carbon double bond ada dua hydrogen atoms. Okay, kalau dia tak follow Markovnikovs rule, therefore the hydrogen atom will be added to the carbon yang paling sikit hydrogen atom, which is dekat sini lah, dekat this carbon double bond. Okay, therefore kalau dia unfollow Markovnikovs rule, this carbon double bond will get the H and this carbon double bond will get the halogen. Okay, halogen apa? Since that kita gunakan halogen Br, so jadinya Br lah. Therefore you can see here, daripada double bond dia jadi single bond now. Okay, dia jadi single bond. Cumanya dekat this carbon previously ni dia akan dapat Br, dekat this carbon atom akan dapat hydrogen, daripada satu jadi H2 macam ni. Faham tak? Okay, so next let's try this out. You can try this out on your own. Okay, for example, kalau let's say you ada this kind of alkene, bila dia react dengan hydrohalogen in the presence of peroxide, what will you get? So you have to remember, dia akan disobey the Markovnikovs rule. Therefore, this carbon atom akan dapat hydrogen. Okay, and then this carbon atom will dapat the halogen. So the product that you will form will be CH3, CH2, C, Br, CH3, and then single bond, because this is an addition process. and then jadi CH3. Okay, daripada CH2 jadi CH3. This is how the product looks like. Okay, kalau for this example, okay, I want you to keluarkan the carbon atom, and then you kira lah this carbon atom dah cukup ke covalent bond dia dah cukup. Therefore this carbon atom memang tak ada langsung hydrogen. Okay, this carbon at least ada 2 hydrogen. Therefore, kalau let's say this is a hydrohalogenation yang with kehadiran peroxide, it will be anti-Markovnikovs rule. Alright, and we will know that this carbon akan dapat dapat hydrogen. This carbon akan dapat Br. Okay, therefore the product that will form is something like this. Okay, jadi ada Br kat sini, and then ada single bond sebab daripada this is addition process. And then since this carbon dia receive the hydrogen, so dia jadi CH3. Faham?